Okay, now let's get started. Today I'm going to just focus on the peak analysis in Origin. So I'm going to cover some general topics like peak findings, peak integration, and the peak fitting. And at the end, I'm going to also show an example how to do a batch peak analysis. Okay, let's get started. So for first example, I'm going to show you how to use a quick peek gadget. So here I have a three spectrums actually. They are I made a stacked Y plot on the graph. And before we do any more like study on like the doing fitting on the graph on the spectrum, we would like to know first about some like basic informations of each peak, like the peak position, peak height, like like a peak width, things like that. Okay, so here in Origin we have these gadgets called quick peaks. So gadgets is like a particularly small tools which is being used on the graph. Okay, so when I click this tool, it pops up this dialog. So without doing anything, I will just show you, like if I just click OK, you see there is a yellow box is put on top of the spectrum. So this is called the region of interest box or ROI box. So the analysis will be focused on the area within this box, and then you can use mouse to change the size of the box. Okay. So right now the analysis is applied on the first spectrum. So it's a quick peak uh, analysis. It will find the peaks on the spectrum. So I just expand the box to the whole range. And the first thing is I want to make some changes to the settings. Okay, to go back to the preference dialog, I can click this triangle button and go and say preferences to launch the dialog. The first thing I'm going to change is the baseline. Okay. Right now it's using the second derivative as the baseline, but I would like to change that to a constant. So let's say I want to use the minimum value of the data as the baseline. Now you will see more peaks are found, and maybe the spectrum itself is a little bit noisy. There might be two peaks found, and we can also apply some smoothing. Okay, let's say I will use the hold on. Let's say I will use the local maximum method to identify the peaks. Okay, and you can also apply a local window. This is sort of like when I increase the window, I will just expand the window to search the peak. It's sort of like apply some smoothing. So you will see one extra peak is removed from this point. Okay. And if I click, another thing is you can go to the quantities tab, and where you can pick which quantities you wanted to export for this spectrum. And also to go to the output to tab. Here, I would like to output the information into a worksheet. Of course, you can output the result to a script window or to a result log. And I would like to see that in the worksheet. Okay. So to output the result, I can click the triangle button again, and let's say new output. So you will see a workbook is generated. I can click it again and say go to report worksheet. And we will see all the informations of the peaks on the spectrum are listed here. Okay. If I want to do the same analysis for the second spectrum, I can click the button and say change data and change that to the second spectrum. So the situations are a little bit different here because these tiny peaks are not found. Okay, I need to go back to the dialog to change the settings. Okay, You can also double click on the yellow region to bring up the dialog as well. And let's say go back to find peak. So here I can go to the peak filtering method by height. So 20 here means if the peak height is less than 20% of the maximum height peak in the spectrum, it will be ignored. So if I lower the threshold, some tiny peaks will be found. Okay, let's say if I change that to 10, so we will see more peaks are found. Let me click OK again. And I would like to export the information of the second spectrum. So I click the new output again. Okay, and you will see the result for the second spectrum are also appended to the worksheet. Let me finish the third spectrum. Switch data, change data to spectrum 3. And I lower the threshold even more in order to identify those tiny peaks. Okay, click OK. Yeah, we just ignore these small peaks. Okay. New output again. Yeah, you will see the results are all listed here. It gives us the spectrum index, the peak index, and the peak positions, peak height, peak area. Okay, and it also has the baseline information, the last column. Okay, this is the first gadget I'm going to show. Next, I'm going to show you how to do peak integration. So this spectrum has multiple peaks, some big peaks and also some tiny peaks. Okay, I want to get the basic information of each peak. This time I'm going to use the peak analysis tool. So you go to menu, analysis, and the peaks and the baseline, and the peak analyzer. Peak analyzer is one of the most powerful tool in Origin that can help you to do peak integration. You can use this to identify the baseline. You can use it to find peaks or to fit peaks. I will use it many times today in today's webinar. So in this, the first page, you can choose a goal. When you select different goals, you will see the steps to achieve the goal will change on the top panel. Okay, so if I choose integrate peaks, and you will see it will go to baseline mode, baseline treatment, find peaks, integrate peaks. We'll go through all these steps. Okay, so I will do integrate peaks this time and click next. So it asks you how you would like to treat the baseline. How do you want to specify the baseline? So here I would say I can just use a minimum y equals 0 line. There are different options here. So for this example, I'll just use constant as baseline. And how do you like to treat the baseline? I can just leave it as it is. Okay, on this step, I want to it asks how you want to find the peaks. So without select anything, let me just click find. Okay, so because this is some ideal spectrum, so data is very smooth. So I use the local maximal method, and it will help. It already finds all the peaks, except that the tiny peaks are not found. That's again because of the threshold. I said the threshold is set to 20% by default. If I set it to none and find again, okay, when no threshold is applied, then you can find all the peaks. Okay, let's click next. Okay, so in the integrated peaks page, you can specify the width, the integration width of each peak. Okay, let me just click the second one, adjust on preview graph. Okay, if I click this, I can go to the graph and select each peak and to change its integration width. I can right click and say apply the width to all peaks. Okay, So now the integration will be applied on the range of the yellow area. And in this dialog, you can also pick what quantities of each peak you want to output. Okay, I just leave it as it is and click finish. Okay, it gives me the fitted. Let's see, where is the? I can find the it's here. So the result is outputted to the second worksheet. Okay, so you get the information of each peak. It's similar to the quick peak gadget that I showed you in the first example. Okay, now let's see the next example. So here I'm going to study one peak, one particular peak for each spectrum. Okay, so let's say I want to study the peak at the range X range 940 to 1000. I can change this X range first. Now we have this mini toolbar to change the axis range. Let's say I want to check this. Okay, I just rescale on y-axis. Okay, so I want to see how the peak will evolve over with the different measurement, different spectrum. I have 5 spectrum here. Okay, this time I'm going to use the integration gadget. Go to gadgets and go to integrate. So I want to make some changes first. So the first is the baseline mode. So you can tell there's the baseline is not a constant horizontal line this time. I will use a straight line. Okay, the straight line is basically just to connect the starting and the ending point on the spectrum to treat that as a baseline. Okay, and I will go to output. So it says output quantities to. I want to output the quantities to a worksheet again. So I check the append to worksheet. Okay, so you can specify the quantities as well, but I leave it as it is. Click OK. Okay, again, I can move the ROI box to cover the peaks. Yeah, I can change the data to check that on the other spectrum. So here I will just show you that I have this option, say new output for all curves. Okay, if I just click this button, it will do the integration on all the peaks on all 5 curves. Okay, then it will be listed in this worksheet. So you will see the height, the area, the center of each peak, and I can, let's say I just select the rightmost 3 columns, and let's say quickly make a plot. Let's do a multiple panel stack plot. So let me change the plot type to line plus symbol. Click OK. Yeah, so this is a quick way that you can see how the peak area and the peak position and the peak width are changed with the for each spectrum. Okay, so this is the peak integration gadget. Next topic, I'm going to show you how to do peak fitting. First one, I'm going to show you the multiple peak fit tool. Okay, so here I have this spectrum. It has 3 peaks, and the first thing you notice that for such spectrum, I assume there's no baseline. So in order to use this multiple peak fit tool, you have to be sure there's no baseline for the data. And let's say if I select this spectrum, and I go to analysis and go and find peak and baseline and choose multiple peak fit tool. Okay. This tool has a very simple dialog. Basically, you just specify the peak function. Let's say I will do Gaussian. And if I click OK, it asks you to double click to pick peaks. Okay. You can use your mouse, find the peak and double click. Yeah, I'm pretty sure these are the point I choose are the peaks where that I want to fit. Okay. So you can just click fit to the origin will just automatically do the fitting. You can also click the second button to open the nonlinear fit tool dialog. So this peak fitting method is using the nonlinear fit tool to do the fitting. You may already be very familiar with this dialog because we have this curve fitting webinar last week. You can go and check the webinar recordings. And here, just to show you that if you go to the settings, and you see that the function is set to Gaussian. And the second thing is, because we have 3 peaks, if you go check the advanced, you will see that the same Gaussian function is repeated 2 times. So we are fitting 3 peaks, okay? And the rest is just the same as doing the nonlinear curve fitting. You come here and you click the fit until converged button, and it will show us that the fit is converged. And click OK to finish the fitting. And you can, yeah, it asks you if you want to go to the report sheet. Yeah, let me just click yes. And on the graph, it gives us fitted parameters small table, and the fitted line is plotted. And you can also use the plot the object manager to, let's say, you can hide the original data and check the fitted curve, the cumulated curve, and also the individual fitted curve. Okay, so you can use the object manager to check that, and it auto generate this nonlinear curve fitting report sheet, all the parameters and its standard errors, and the fitting statistics table. You can check the R-square value, chi-square, and tell how the fitting is. And it has the ANOVA table. Okay. Okay. So just to be cautious that if you want to use this tool, you need to be sure no baseline treatment is needed for this spectrum. Okay. Let's go and check next topic. Now I'm going to fit a more real data. Okay, so this is our spectrum. Yeah, by just looking at it, it is very noisy, and also maybe we can't just use a constant as a baseline. Okay, and there are some tiny peaks on each side, and it might also have some hidden peaks. Okay, so if you can say here is a small peak at the shoulder, and this time I'm going to use peak peak analyzer tool. Okay. Okay. So this time I'm going to choose fit peaks as goal. Let's click next. So for baseline mode, yeah, the constant using the minimum value doesn't look very good. And you can use, for example, you can use straight line. It's just to connect the starting and the ending point. Okay. And you can also use endpoints weighted. Let me choose this baseline mode. It uses like a certain percentage of the starting and ending points and use that and connect those points as and treat that as baseline. So it seems better, okay? So I just use this method, and you can choose whether to subtract baseline now. Yeah, I can just subtract the baseline. Okay, now I come to the peak finding page. So let's say if I just without doing any settings, let me just click find. Okay, it finds 17 peaks. We know that most of them are not actually peak, they are just a noise. So one thing we can do is you can apply some smoothing. Okay, let's say I increase the smoothing window to 10 and then click find again. Okay, it finds the less peaks, which is nice, but we notice that the hidden peak on the shoulder is not found. That's because we're using local maximum. These points are not maximum, right? So this time I'm going to change the method. Instead of using local maximum, I'll use a second derivative. Okay, and click find again. Okay, so because now I'm using the second derivative curve to find the peaks, so I need to do smoothing on derivative curve as well. Let's say I will use the Savsky-Gley method and click find again. Okay, nice. The nice thing is this hidden peak is found this way, and we can also like increase the smoothing. Let's apply more smoothing, for example, like let's do 40. Okay, and now I assume the big peaks are all found, but if we still want to find these tiny peaks, we can lower the threshold. Say let's do 5. Yes, those peaks are very tiny. Let's do 3. Okay, so these tiny peaks are also found, and maybe you want to add the leftmost small peaks, and you can also uncheck the auto find box, and let's say I want to manually add one peak. Okay, okay, so now all the peaks are found. Then I will click next. Okay, now it's on the fit peaks page. Here you can find this fit control button. If you click it, it will open a dialog which is similar to the curve, nonlinear curve fitting dialog. It has this parameter table, and it first of all it shows which peak function you can choose from. Yeah, I just use Gaussian, or you can change to other peak functions, and it lists the peak index 1, 2, 3, 4, 5, 6, and so on, and the peak parameters. And you can share the fitting parameters among peaks, and you can also fix the peak parameters. I will show example in a moment, but right now I will just let me make the table a little smaller, expand the blur. So this is a peak function that I'm going to fit the spectrum. Here yeah, there's some like buttons here. So for example, this one's how you want to show the peaks. Okay, and you can also sort the peaks, the peak indexes. And these 3 buttons are to fix the this one is to fix the baseline, fix the peak center, and fix the width. Okay, and if I just click the fit until converged button, say it's already did a pretty good fit. Okay, and if it's fitting is not good, you can also go to the bounds tab here. Sometimes the peak will get into some crazy, it will fit to some crazy parameters, values here, and you can apply some bounds to each parameters. Okay, let me click OK. And again, in this page, you have more options, like how you want to customize the report table, and how you want to customize the report graph, and you can just go and play around with that. If I click finish, okay. First, it gives us this report graph. It has this um, graph with the original data and the fitted curve, and it lists the fitted parameters in this table. And also it generates this report sheet where you have all the information, like the baseline information, you have the parameters list, and you have the statistics of the fitting ANOVA table. Yeah, this is a similar report sheet as the nonlinear curve fitting tool. Okay. Okay. Other than the peak analyzer tool, I'm also going to show you the one app called peak deconvolution. This app um, is similar to the peak analyzer tool. It's just to combine all these two steps into just one dialog. Let me just launch this peak deconvolution app. So if you don't know what the app in Origin is, I'll just say a little couple of words about it. Here we have this apps panel. So apps are just some small tools which are not delivered with Origin, but you can download from our website for free. And you can click this Add Apps button to launch the App Center dialog. And where you can just find the apps and click the download button to download. For example, you can just go to search, let's say peak deconvolution, and find the apps that you want and click to download. And you can also click the app name to open the web page. It has the more details on each app, okay? On what the app is doing and how to use it, things like that. Okay, okay, now I already downloaded the peak deconvolution app. So with this graph activated, I'm going just to launch this app. Okay. So you see the by default the spectrum is shown on the graph, and the baseline is showing as red. And you can select the baseline model. So here I will just say straight line. Okay, just use a straight line as the baseline, and you can also subtract the baseline. Oh, it just closed it. Sorry. Again. Yeah. So let's say I will choose straight line as baseline, and the second tab is peaks, where again you can you can set the peak finding algorithm. If you click this yellow button, it has this similar options that in the peak analyzer to how you want to specify how to identify each peaks. Okay, but this time I will just manually select the peaks on the graph. Okay, let's say I click add. It just make have this big picture of the spectrum. I can just use mouse to double click on the peaks. We already know that these are the peaks that I want to fit. Okay, and click down. Okay, so the default parameters are the fitting parameters are initialized and show on the graph. Okay. There are other settings like you can show the second derivative, and show the residues. Okay, and you can also to modify the initial guess of the peaks on the graph. But I just leave that to you to play around. And also there are other options to how do you want to show the peaks, like the labels, thing like that. And there are also those options like you want to if you want to fix the peak parameters. Okay. Here I can also apply bounds. Let me just do the fitting first. If I just go and find this fit until converge button. Okay, so it's already fitted properly. And again, if you wanted to apply bounds, let's say here, if I want to apply some bounds for the width, like you can just type the lower bound and the upper bound, and you can click this button to apply the bounds to all the peaks. Yeah, if I just click this button, maybe I need to reinitialize the parameters and apply the. Okay, so for some reason it's not working this time. Yeah, but just to let you know that you can apply the bounds for each peak. You can set bounds for each peak in the fitting. By just fit it again. You can click this button to generate the fitting result. Yeah, it generates a table. And okay, something is not right. Okay, yeah, you can play around a little bit later. Okay, let me go to the next example to fit a peak with baseline. So in this spectrum, I have this obvious baseline, which has a shape of an exponential decay function. And I also have one positive peak and one negative peak. Okay, so I want to let Origin to adjust the baseline. Let me go to analysis and again go to peak and baseline, peak analyzer. Okay, so let's say I will do fit peaks. So for the baseline mode, this time I will use user defined. So by selecting this method, Origin will add some anchor points to the spectrum. So by default, it adds 8 anchor points. So anchor points is where we use that. These points are on we assume these points are on the baseline of this spectrum. And you can either connect these data points, anchor points, or you can do a curve fitting based on these points to create a baseline. So again, increase the number of baseline, let's say 20. So more data points are added. So Origin just find those like area which curve are more flat, which are more likely to be the baseline area. You can also add some anchor points if you want. Go to next page. So here you can do an interpolation. You connect these lines by line interpolation or spline interpolation. You can also use a fitting function to fit a curve to these anchor points. Let's say I want to fit with an exponential decay function. And even I can do an exponential too. So It just fit it with two exponential function. And click next. And I can subtract the baseline. Okay. And these peaks, two peaks are very obvious, and you click find to identify the two peaks. And click next. Again, I can just fit until converge. Click OK and click finish to get a report sheet. Okay. Okay, next one, I'm going to show you how to share the fitting parameters among peaks. So here I have 4 peaks. They are of a different height, but maybe I want to share the width of the 4 peaks during the fitting. Okay. Again, I'm going to use the peak analyzer tool. Okay, choose the fit peaks as goal. And for the baseline mode, I would say we're pretty sure it's a horizontal line at the center, right? So let's say I do constant, and I can use a mean value or a median value. I think median value is better. Okay, just choose median as the baseline and then click next. Next. Again, these are some ideal data, so it's very smooth. So if I simply click find, it will successfully find all the peaks and click next. Okay, let me click fit control. Here, this time I'm using a mixture of Gaussian and Lorentzian curve, so viewed. If I click the formula, it's a complicated peak function. It's a convolution of a Lorentzian and a Gaussian function. It's here, okay. So the first f1 is a Lorentzian and the f2 is a Gaussian function, okay. So this function has two widths, wg1 and wl1. I want to share the Gaussian width among all the peaks and also share the Lorentzian width among all the peaks. So I can click the share, set the Gaussian width to 1, and I right click on the 1 and say apply same share to all WG. And then I set the Lorentzian to 2, and I can share the Lorentzian width to all the peaks. Okay. And then I do the fitting. And of course, you will see the Gaussian widths are all fitted to be same among the peaks. Okay. Yeah, this is an example of how to share the fitting parameters. Okay, let me click OK and finish. And in the report sheet, you can also see that the shared parameters has this star on the parameter name, okay, indicating these are shared parameters. Okay. Next example, mixed line shape. So this is another example that one spectrum has two line widths. The first one looks like a Lorentzian peak, and the second one is like a Gaussian peak. So how can I fit one spectrum with different peak functions? Okay. Again, I will go to the peak analyzer tool. Use fit peaks as the goal. Yeah, I can use the minimum as the baseline. Find a peak. Yeah, because there's some noise on it. I can, let's say, add some smoothing. Okay, now just 2 peaks are found. Next. and go to fit control. So by default, just two peaks are all Gaussian function, and if I click fitting, you can tell the fitting of the first peak is not very good, right? So I want to change the first peak to Lorentzian. Okay, I just go to the peak table and click the peak name, and it shows this drop-down list, and you can select Lorentz. Okay, right now the first peak is changed to Lorentzian. Just reinitialize the parameters, click fit again. Okay, now you see the accumulated peak are like aligned with the data. And click OK. And click finish. And click OK. So it says the first peak is Lorentzian and the second peak is Gaussian. Okay. Basically, you can change the peak function of individual peak in your data set to do the fitting. Okay. There's still some time. I'm going to show an example on how to do a batch peak analysis in Origin. Okay. So here I have a data set. It has 8 Y columns. So this is the what we call the ESR experiment. So a crystal is placed with different angles to the magnetic field, and the scientists just increase the magnetic field and measure the absorption power of each crystal. So at each sample orientation, they measure the one spectrum. Okay, if I plot out the spectrum for different angles, and you see this stacked spectrums. So for each angle, you can tell that the peak is evolved. Okay, it has some trend to moving to the right with when the sample directions changes. Okay, so here I'm going to show how I can analyze all the spectrums all at once and create a summary sheet of the spectrum of the peak position. Okay, so the idea is that I can do a peak analyzer on one spectrum first, and I use the peak analyzer tool I just showed you to do the fitting. What I'm doing is I save the information or save the information of the settings of that dialog and use the same settings to do the analysis for all other Y columns. Let me start. Okay, so I start with the first spectrum and I go to analysis and peak and baseline, peak analyzer. Okay, so let's say I want to do peak fitting. So here I can use again I can use a user defined. So to do a batch processing, you need to let Origin to automatically specify the baseline. So here I use the user defined baseline mode, but I will check this auto find box so that Origin will automatically find the baseline anchor points. Okay. So next. So I do some interpolation. I will just use a spline and click next. Next. Here I'm going to find the peaks. Because again, here is the one peak on the shoulder. I will use a second derivative method, so to find these hidden peaks. Okay, but there are, yeah, I can increase some smoothing. Okay, but still, I assume there are two peaks on this left mountain and one peak on the right mountain. So basically, I only want to find 3 peaks. So I can set the filter of the peak. Let's say I can filter the peak by number. Let's say I only want to find 3 peaks. Okay. Some other peaks may due to the noise, and I will just ignore those. Okay. Right now, only 3 peaks, 2 from the left and 1 from the right. These are the peaks I want to find for each spectrum. Okay. Let's click next. I can go to the fit control dialog and do the fitting and click OK. Okay, so before I close this peak analyzer tool, I go to the dialog theme on the top. Here's the button. I will save this as a theme. Save this, save as. So theme is like a group of settings in this dialog. So I'm basically what I'm doing is I just save this all the settings I just made into a theme file. Say my theme, give it a name. So here are many checkboxes, and you can specify which settings you want to save and which you don't want to save. Okay, so override it. Let me click finish to finish the peak fitting and go to the report sheet. It generates a couple of worksheets, and I'm just going to show you the peak properties sheet. So this is the worksheet that I want to export for each spectrum. Okay. This will be used in the batch peak analysis tool. Okay. Now I already saved the theme and I can run the batch processing. Let me go to the analysis and the peaks and the baseline and the batch peak analysis using theme. Okay. Just click this one. Okay. So here for the input, and I can click the hunt button and I just select the entire worksheet. So it just tells Origin that I want to do batch processing or for all the Y columns. Okay. So here it's already selected. The Y column is from column B to column I. Okay. And go back to the dialog. And the theme, I will use my theme I just saved. Okay. And for the result sheet, I will choose the peak properties. Remember, I just showed you that the peak properties sheet is where I want to see for each spectrum. And you can specify a summary sheet name. And you can delete intermediate result if you want. And if you want to check the fitting for individual spectrum, you can uncheck this box. And for the data set identifier, I would like to use the sample directions. Okay, say I click this button and say sample directions, and I just remove the range. And just to make sure that you are going to append the result by rows, okay, in this case. Then I just click OK. So it will run batch processing for all the spectrums in the worksheet. Okay. Now you see all the informations for the 3 peaks. Sorry, 3 peaks for individual spectrum, and the spectrum are identified by the directions. Let me just quickly make a graph from it. So I can change the sample direction column to X column. And let me select the center position. Sorry. Center position column and make a make a XY scatter plot. Okay. Okay. Let me just rotate the graph 90 degrees, and I can color its point by the peak index. Say peak index. Okay. Regenerate the legend. Okay. Now you can see how the peak positions are moving to the right when the sample the angle increases. If you go and compare with this spectrum graph, it matches, right? So you can see the peak position is moving to the right. It has the same trend. Yeah, so this is how you can run a batch peak analysis on the spectrums. And okay, so I think that's it for today's webinar. And um, again, I will just show you this page that if you go to our web page and go to the upcoming webinars page and all recorded webinars, where you can find all our recorded webinars. Okay. Okay, again, thank you for attending today's webinar, and have a nice weekend.